You mentioned causal inference there a few times in our chat, and I'm curious if you can unpack that for listeners. It was a new term for me just a couple months ago. Like causal machine learning takes causal inference a step further when we're talking about this in the incrementality context. Instead of like using statistical methods to identify causal effects, causal machine learning uses machine learning to
Yeah.
estimate causal effects. Can
Yeah.
you break that down for us? Like, is it true that causal ML is a way to move beyond simply identifying correlations to understanding the underlying mechanisms that drive outcomes, it basically allowing us for more robust, explainable models? Break that down for us.
Yeah. Absolutely. Absolutely. So, a causal inference is an umbrella term, and the most popular way of doing causal inference that perhaps everyone has heard about is the clinical trials when it comes to testing medicines, right?
Mm-hmm.
So let's take an example. So there is a medicine that you want to test whether it cures someone of a disease. So you've created a treatment group of people. You give them the medicine. You wait for some time, and then there's another group of people to whom you give a placebo. You wait for say a few weeks and see if the people who got the medicine are they better off than the other group. And let's say you get good results, right? Now, if you look a little deeper, perhaps your treatment group was all female, age between 25 to 45, and your control group was all male, perhaps age less than 25, right? Which means they were incomparable to start with, right?
Mm-hmm.
So this is the case of, can we infer causality from correlation? You're observing correlation, but in this case you cannot, because there's bias associated with it.
Right.
How to de-bias? You should have both cohorts with similar composition, right? That's where randomization comes in, right? So
Yeah.
if you're testing this to understand the efficacy of this drug in Canada, then your treatment and the control group should have the right representation of Canadian population, right? That's when
Yeah.
that's when it's comparable. Now, this is causal inference. This is causal inference where we are controlling for the bias by treating or by designing an experiment properly and running the experiment for a few weeks and making some inference out of it. Now, the truth about marketing is everything in marketing is quasi-causal in some way, because we don't have a laboratory setting where we could test Facebook's efficacy. Right? It is getting tested in the real world. And that's problem
Mm-hmm.
number one. Problem number two is, once a drug is tested, you are you have discovered a universal truth about that drug. But that's not true about Facebook's performance for your business, right? That is going to change next quarter, the quarter after that. So the testing here, you're not discovering any universal truth. You are discovering that Facebook is working for you today in this season. You have to repeat
Mm-hmm.
this in another quarter, right? So from that perspective, everything in marketing is slightly quasi-causal always. Now, in causal ML, what we are doing is this is a very important approach. Right? Geotesting essentially does this. Instead of taking individual cohorts, we take geography cohorts, and that has got its own utility, right? Because geotesting is a common framework which can do apple to apple comparison between Facebook and Google and TikTok, because it's a common testing framework. You cannot get something similar out of platform lift studies in Facebook, right? Because it's sort of a black box. Though there are a lot of documentation, it's still a bit of a black box. So you can't compare Facebook to Google by just relying on Facebook and Google platform list study. So that way,
Mm-hmm.
geotesting is very, very, very useful. Now, coming to causal ML, so there's this field of causal AI, right? The whole philosophy here is we could find smart experiments hidden within your historical data, right? So, and that's a faster way to observe a few things. And in a lot of cases, this is the only ethical way of doing things as well. For
Mm-hmm.
example, if we need to understand the impact of smoking in cancer, right? We can't create two group of people and get one of them to smoke, right? So that's not ethical. So we'll have
Yeah.
to infer things from the data that's out there,
Uh,
and this is a Nobel Prize winning idea. In 2021, the Nobel Prize went to this causal inference on observational data, right? So that's when this term called natural experiment sort of became very, very popular. Now, the problem with most of the algorithm that is emerging out of the causal AI spaces, they don't have the kind of maturity, I would say, when compared to the ML algorithms that's very popular in the industry. So, for example, if you're familiar with supervised learning or regression-based approaches, right? So there
Hmm.
you have certain framework to understand accuracy, understand fit in terms of R square. You could do back testing, right? You will get the ground truth data, create a model and test the model on some holdout data. So there's some framework that is very evolved and matured in the ML side, which is not that evolved in the causal AI space. So what we are doing is we are adopting certain approaches from the causal AI space. One specific approach is this thing called structural causal modeling, which is when we see all the data, we try to first impose certain assumptions on how these variables are interacting with one another. And on top of that, we apply regular ML. Right? It could be Bayesian regression, ridge regression, or whatever. But what this enables us to do is when it comes to MMM, there are a lot of implicit assumptions in data transformation, in the way the variables interact with each other, and all of that.
Hmm.
So all these assumptions can be properly codified into the causal graph, and that becomes a very useful uh, communication layer between the modeler, between the data scientist and the marketer, right? So in the causal DAG, uh, we could have things like so your top of the funnel variables, they are driving your Google brand search spend, right? So Google's brand search spend is not an independent variable. You tend to spend more in Google brand search if your TV ad is working really well for you, because a lot of people would come and search for your brand. So there's this interaction, right? If you think of this from a regression perspective, these are just two variables. And the assumption is that they are independent of one another in any regression modeling, right? There's this assumption called independently and identically distributed assumption, right? So we assume that they are independent of one another, which is not true, right? They are dependent. Your click-based variables, if you're paying per click, you would end up more click if your top of the funnel is really working for you, right? So these assumptions are first encoded in some causal language, and then we use regression approaches to understand the true impact. So this way, some of the time-tested ML approaches in MMM, right, which is your regression-based approach, essentially, right? The different ways in which you could transform the data, you could do time series decomposition, and a bunch of different things, are brought into the world of causality, and you have a hybrid solution. Eventually, perhaps a better causal AI algorithm might evolve, right? In which case, you perhaps don't need causal ML. You could do everything in causal AI, but currently that's not the case, right? So I mean that's uh, I hope it all made sense. So that's how that's the whole spectrum of causal inference. You have experiments and you have natural experiments, right? But natural experiments has got its own limitations as well. So if your
Mm.
data is sparse, so you have a new variable
Right.
which is very sparse, the model would struggle to truly understand its impact. That's when you should go to the experiment, right?
Very cool. Like, the thing that stands out to me, and I appreciate your detailed breakdown there. Like the difference between how causal AI thinks of experimentations is, instead of going out and doing natural experiments in market and figuring out, the design of that experiment and babysitting it, like you said in your previous answer, we're instead looking at historical data and trying to uncover hidden experiments
Yeah,
that are within data that we already have,
yeah.
and then we can infer causality based on that. Is that the right way to think about it?
Absolutely, absolutely, yes.